In the first section of chapter 12, we talked about circumference of a circle, which is the distance around a circle, like perimeter, but with a circle. And then we talked about arc length, which is just a piece of the circumference. And in this lesson, we're going to talk about area of a circle, and then we're going to talk about just a part of the area, or the area of a part of a circle. That's called the area of a sector. So we've already, in this course, used the formula for the area of a circle. And just to remind you, that formula for the area of a circle is area equals pi times radius squared. Let's go ahead and do a problem where we find the area of a full circle. So here we have a circular gauge, and they gave us the radius, and they ask us to find the area rounded to the nearest hundredth. The formula is area equals pi times radius squared. The radius they gave us was 2.5 centimeters. When we put that whole thing into the calculator, including the pi, we end up with 19.63 centimeters squared. Remember, the units on area are always in square units, like square centimeters in this case, or square inches, square feet, square meters, and so on. Let's do another problem with area of a circle, but in this problem, we're going to find something other than the area. So here we have a circular disc, and they've asked us to find the area, or asked us to find rather the diameter. Now, the formula for the area of a circle, pi r squared, doesn't have the diameter in it. But if we can find the radius, we can then multiply it by 2 to find the diameter. So they've given us an area. That's going to go in for our A, 113.1. And I'm going to leave the units out. We don't have to put them in our work. Pi r squared. We need to solve this then for r so that we can get the radius. To remove the pi, we're going to divide by pi on both sides. The pi's will cancel, and that leaves us with r squared equals 113.1 divided by pi. And as we've seen already in this chapter, we need to take the square root of both sides. Now, normally you get two answers, a positive and a negative, but the radius of a circle can't be negative, so the radius is really the square root of 113.1 divided by pi. We're not going to put that into our calculator yet because we don't want to round it. We're actually trying to find the diameter. Since we want the diameter, we have to multiply the radius by 2. So we'll take 2 times the square root of 113.1 divided by pi. And that's what we'll put into our calculator. And we'll round it to the nearest hundredth, so 2 decimal places. The diameter here comes out to be 12.00 centimeters. And we do have to put the units on our answer. Now, it would not be counted wrong if you didn't put the 2 zeros, because we don't make you write those zeros just for holding places. Let's talk about the area of just a part of a circle. A part of a circle is actually called the sector of a circle. A sector is sort of like a slice of pizza. So that yellow shape there is called a sector. And to find the area of a sector, we use the fraction of the circle, like we did for arc length, times the area of a circle formula. Let's go ahead and try a problem where we find the area of a sector. In number 3, we're asked to find the area of a sector, and it says to leave it in terms of pi, and that'll become important in just a little while. So if I'm finding the area of the sector, that would be the pink region there, I need the fraction of the circle. So it's 70 degrees out of 360 degrees times pi, and then the radius was given to be 8. Now, because it says in terms of pi, we will not put the pi into our calculator. So this will be in our answer. So the area of the sector if we put the 70 over 360 times 8 squared into the calculator, we get 112 over 9 times pi, and there were no units given, so we don't have to put any units on our answer. Let's try another problem. Let's try another problem where we find an area of a sector and we leave it in terms of pi. So this one actually tells us to find the area of the whole circle. Remember, the formula for the area of a circle is just pi times radius squared. All we need to know is the radius, and they gave us the radius here. The radius is 14 feet. In terms of pi, we would take pi times 14 feet and then squared. In terms of pi, we do not put the pi into the calculator, so we end up with 196 pi, and then the units would be square feet. Same diagram on the next problem, but now I just want to find the area of sector FDE. That's that pink sector. So we're finding the area of this. To find the area of the sector, we need to first have the fraction of the circle. 120 degrees over 360 degrees times pi times that radius squared. And to the nearest tenth means we're going to have one decimal place. So the area of that sector would be equal to 205.3 and then feet squared. This time we would put the pi into the calculator. Let's find the area of the blue sector. So if we're finding the area of the blue sector, we need to know the degrees for the blue sector. We need the measure of that major arc FGE. Well, a full circle is 360. We'll subtract the 120 that is the pink sector, so the measure of that major arc, FGE, comes out to be 240 degrees. Then the area of that sector will equal the fraction of the circle, 240 degrees out of 360 degrees, times pi, times the 14 feet squared. Once again, we're asked to go to the nearest tenth. So the area of that sector would come out to be 410.5 square feet. Let's try another example. In this example, it asks us to find the area and the central angle that goes with the sector BVC. Well, the central angle we can easily see. The central angle is given to be 40. And they actually ask us to find the area of the entire circle. The area and the central angle were given, and they gave us the area of the arc, or the area of the sector. So really, they've given us information about the part, and then they've asked us to find the area of the whole. We're going to use a proportion, just as we did in the first section. We're going to compare the part to the whole. For the part, the angle is 40 degrees. For the whole circle, the angle is 360. For the part, the area is 35 meters squared, and we're looking for the area of the whole. We'll cross multiply. 40A equals 360 times 35 comes out to be 12600. We divide by 40 on both sides. We find the area of the circle comes out to be 315 meters squared. Anytime you're given information about the sector, the part, and you're asked to find something with the whole, you're going to use those proportions. Here in number 8, we are once again given information about the part, the pink sector, and we're asked to find the area of the whole circle. So again, just as in the previous problem, we're going to use a proportion. And we're going to compare the part to the whole. This is the angle for the part, 85 degrees. The angle for a full circle is 360 degrees. This is the area for the part, 214.37 centimeters squared. And we're looking for the area of the whole circle. And now comes the cross multiplying. 85 times A, of course, is 85A. 316 times 214.37 is 77173.2. We divide by the 85 on both sides. And then we're asked to round it to the nearest hundredth, so that's 2 decimal places. We get 907.92, and the label is centimeters squared. So in these last 2 problems, you've seen that whenever you're given information about the part and you're asked to find that same information about the whole circle, that's when you use proportions. This next problem is a composite shape. It's a composite shape like we had in Chapter 9. This composite is made up of a semicircle, half of a circle, plus a triangle. To find the area of a semicircle would be half the area of a circle. The area of a triangle is found by taking 1/2 base of the triangle times height of the triangle. Now, in this particular problem, they did not give us the radius of the semicircle. Instead, they gave us the diameter. So the diameter is 7. The radius, then, is 7 divided by 2, so the radius is 3.5. So when we put that into our formula, we have 1/2 pi times 3.5 squared plus 1/2. And then when we're talking for the area of the triangle, we know that the base and the height of a triangle have to be perpendicular. So the base and height will be the 7 and the other 7. Since it asks us to round to the nearest hundredth, we'll put that whole thing into our calculator. Rounding to the nearest hundredth means 2 decimal places. 43.74, label is meters squared. A composite shape, you have to add or subtract. In this case, we had to add a semicircle, half of a circle, plus a triangle. Number 10. Number 10, they ask us to find the area of the shaded sector. And they actually give us the arc length, and they give us the arc measure. So the first thing we have to do is we have to find the radius. We're going to find the radius using the arc length. The arc length is what we just learned in the section before this. So that's the L. 2.40 is the L. The arc measure is 60.63 divided by 360 times 2 times pi times the radius. And we need to solve that for the R. As I've suggested in the past, it's best to eliminate fractions. So we're going to multiply by 360 on both sides. Now on the right side, that will cancel the fraction. We'll still have the 60.63 times the 2 pi times the r. And on the left side, when we take 360 times 2.4, we end up with 864. To get the r by itself, we have to divide. We'll divide by the 60.63 and the 2 pi. Everything on the right side you can see will cancel now except the r. So the r is really 864 over 60.63 times 2 pi. We don't want to put that into our calculator because that's not our answer. Instead, we want to use that in our formula to find the area of the sector. So to find the area of the sector, we take the fraction of the circle. Well, that was 60.63 degrees out of 360 degrees times pi times that radius that we just found, squared. And we'll want to put that all into our calculator. I want to remind you that when you have more than one thing on the bottom of a fraction, be sure and enclose that in its own parenthesis. When we put that into our calculator and we round to the nearest hundredth, we come up with an area that's equal to 2.72 centimeters squared. So this section dealt with the area of a full circle and then the area of a part of a circle called a sector of a circle. The section before this dealt with circumference of a full circle and then the arc length, which was the part of the circumference. Good luck on the practice. Remember, I'm available from 2 to 4 for help during the school days. Take care.